Alright, so let's look at some equations here. So the first thing we want to do is look at a circle equation. Just going to do some simple ones. So here's one, r equals 3. So how do I know this is a polar form? Well, it's got the r in it, and it doesn't have an x and a y. So if I were to make an x, no, I don't want x, I want r. If I were to make an r theta chart, just like an xy chart, r is 3 when theta is, let's say, 10 degrees, and r is 3 when theta is 50 degrees, and r is 3 when theta is 180. You get the idea here. So no matter what theta is, r is 3. So if I were to graph that, I'm going to get a circle with a radius of 3, and this is what it looks like on my calculator. So in my mode, I'm in polar mode, and my window, I've set my window from 0 to 360 because I'm in degree mode. If you were in radian, you could simply do this in radian. You would set it from 0 to 2 pi. And I am just chosen my theta step as 10. You can play around with that a little bit. And then I've just got my x and y window set. Actually, I set the x, here, I'm going to show you something here. I set the x originally at negative 5 to positive 5. And then when I graph that, and I already have this into my r equals, let me show you that in r equals 3. And when I graph it, it's a circle, but you get kind of a flattened circle and more of a ellipse looking on the calculator. So you can go to your zoom, and you can go down here to number 5, no, go back up now. So zoom square, and that just squares up your axes a little bit. So a circle really truly looks like a circle. Alright, so that's a circle with your calculator. So we want to convert this to rectangulars. And recall from a previous math course that the equation of a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where the coordinates h and k is the center of the circle, and r is the radius of the circle. Alright, so let me take you through the process of converting this. And let me start with a new piece of paper. So I've got r equals 3. Alright, so the first thing we want to do is we want to, I'm going to write my step directions over here. So we want to square both sides. So let's do that a minute. R squared equals 3 squared. So r squared equals 9. And then step 2, recall that x squared plus y squared equals r squared. Remember the little triangle picture? Here's your x, here's your y, here's your r. So because this is true, then I want to make a substitution. So let's substitute this in for r squared. So on the left hand side I'm going to have x squared plus y squared equals 9. And then I'm able to identify the center of the circle, which is 0, 0 in this case. That's the center. And then the r, well, that would be the square root of 9, which is 3. So there you have successfully converted an equation of a circle from polar form to rectangular form. And before I leave this example, if I just asked you which one looks simpler, well, r equals 3 in polar form certainly looks a whole lot simpler than x squared plus y squared equals 9. Although that one's not bad. Alright, let's do another one. Alright, so here is an equation. equals 8 secant theta, and I can graph it to look at that. Let's graph that a minute. When we graph it though, we're going to have to graph that as 8, and then we've got 1 over the cosine. That's our secant. Let's pull that up and graph that a minute and see what that looks like. So let's clear this, and we have 8 parentheses 1 divided by cosine theta, close parentheses, close parentheses. And I may have to open my window a little bit because I've got 8 here. Alright, so those are good. Let's let my x go from -10 to +10. Let's see how this will work. And my y, same thing, -10 to +10. Okay. And then when I graph that, I have a vertical line. Here's my table. This may or may not be helpful looking at the table. Not really, that doesn't really help to see that that's aligned by looking at that. Okay. Alright, so let's go back and convert that now that we know what we're looking at. So we want to convert this to a rectangular form. So when we graphed it, we saw that it was a line. Looked like it was over here somewhere. So it was a vertical line, and you will recall that for lines we use y equals mx plus b, and this isn't going to work for this equation because there is no b. It looks like a vertical line, so there's no y-intercept, and the slope, well, that's a vertical line, so that's undefined, so that doesn't work. So you might recall that this line is just going to have the equation x equals, and I'm assuming it's going to be x equals 8 because there's an 8 there, but let's convert it and let's take a look at it. Alright, so the first thing we want to do is change it to cosine, which I did over there, so just let me recopy this. 8 times 1 over the cosine of theta, and I don't really need my parentheses, let me get rid of that, and I'm just going to put my multiplication in there. Alright, so now I want to multiply both sides by cosine theta, so I end up with r times cosine theta equals 8, and then I recognize that r times cosine theta, well, that's my x, so I can make a substitution there, and I get x equals 8. Remember from our, when we did converting there, here's your theta, and this was your r, so we've got the cosine, my x, the cosine of theta is equal to x over r, because that's my adjacent side. Alright, so there's my equation, x equals 8. Now in this particular case, here's the polar form, and here's the rectangular form. In this case, actually, the rectangular form looks a little easier than the polar form, but again, just an example of converting that polar form of a line to the rectangular form.